Good afternoon and welcome everyone to our expert-led workshop for the hands-on labs for Data Services Manager. My name is Kim Delgado and my pronouns are she, her.
And my name's Peter Curran. I'm a staff cloud architect and my pronouns are he, him.
So today we're going to give you a little bit of an overview of the solution and then we'll walk through a couple of the modules that you can do on your own as well to walk through the solution using both the API and the UI to deploy and manage databases. So why are we looking at Data Services Manager? What are the customer needs that we're addressing with this solution? The first one really comes down to constraints on that all IT teams face today in terms of resources and the general high demand and high turnover for databases that are needed for developers and your environments today. So being able to efficiently manage both the creation as well as the day 2 operations, the backup operations, and the security operations for databases is becoming more and more critical. When we have application developers trying to continuously spin up and build and test new code, they often have to create new databases on the fly, and that can often be a fairly lengthy database. That can often be a fairly lengthy amount of wait time to get those databases. We do have automation tools that allow you to script spinning up databases, and that's great to actually spin up a virtual machine and maybe install the software. But if you don't have the ability to manage them, make sure that they're kept up to date. If they are longer living databases, make sure that they have all the security patches applied and all of those sorts of things and back them up regularly, then that can be problematic as well. So being able to take an approach where we set up policies that are managed by both the infrastructure team and maybe the security team to make sure that all those policies are in place, then application developers can request their own databases very easily without having to worry about having multiple teams involved in that process. And of course, security and compliance folks want to always make sure that they have their components addressed as well, making sure that everything is patched, and when we have all these lots of different types of databases as well as so many instances of databases, that can become hard to manage. We've kind of moved away from the time when we had a few large central databases that were easier to manage, maybe on a physical machine or a large virtual machine. Now we kind of spin up separate virtual machines to support databases for each application or each application instance. So typical provisioning process for a database in an IT department would generally involve the application developer or the person who needs that database to submit a request of some sort that goes to the infrastructure team, and they need to make sure that they have the necessary infrastructure, storage, memory, all of that to create a virtual machine itself. And then compliance needs to make sure that that virtual machine meets all of their compliance requirements. And then the actual database software needs to get installed or provisioned, the platform, and then the actual creation of the database instance. And then it's ready for that developer to actually use that database in their application. The challenge with that is that oftentimes this process, depending on how well automated this is and if there are manual approvals or manual steps involved, can really take anywhere from a few hours to a few days. That's a lot better than it used to be in the old days when we used to have to provision servers to create database servers and all of that, but it still can be a fairly lengthy process to get all of the components completed correctly. So that is why we are looking at, that's why we've addressed the part of this, that's why we've addressed a lot of these concerns using Data Services Manager. It provides that simplified operation through a simple UI that, along with an API that is very that's also very robust. We can deploy and manage these open source databases and commercial databases consistently on vSphere. Everything is ready for the developers. It's a developer-ready infrastructure, so developers can request via the API, or it's very easy to leverage the API through your other request processes, such as ServiceNow or ARIA automation, to be able to request these databases. But also it gives you that peace of mind because you have those policies in place that the developer doesn't really need to know anything about or worry about, but we don't have to then have manual processes to configure your backups, your security, all of that to keep your data secure. Because the reality is, even if developers just have developer databases that they're using for testing, they often have some amount of real data in them, and so we want to make sure that that data stays secure as well. It's not just that we have to worry about the data in production. And we also need to make sure that everything is patched and always up to date, because that can be, we don't want to introduce attack vectors for bad actors as well, even in our dev test environment. So let's take a look at what the solution looks like in your environment. This is a little bit high-level overview of the infrastructure, the physical architecture, the virtual architecture of the solution. So we have a provider virtual appliance that does require a fair bit of some storage components for provider logs and provider backups, and a repo as well for at the provider layer. We have agents, and you can have one or more agent appliances depending on your environment, and that those agents are the ones that actually deploy and manage the databases. And those agents need to, again, have their own backup storage. They need to have storage for the templates that we're deploying and all of those sorts of things. So we can use either actual S3 buckets in Amazon, or we can use solutions that mimic S3 buckets on-prem, which is how we have the lab set up in this case. Everything is that's set up in the hands-on labs that you use today mimics everything being deployed in an on-prem solution. And then of course those agents actually deploy those database virtual machines and then manage those virtual machines, whether that's Postgres or MySQL or even SQL Server. So we also have a variety of logical constructs that we need to configure within the application. And I like to kind of like lay this out because it can be a little bit confusing if you're just looking at it through the UI. We have environments that we set up, which are really just resource pools or clusters, and those are set up and managed by the provider, someone in the provider organization, which is kind of the default tenant. And then we can have multiple organizational tenants set up with users, both administrators and users, that have access to the resources that we set up in namespaces. So you can each organization can have access to one or more namespaces, which is really just a set of compute resources, right? So we have our data stores, our networks, our compute, all of that, and then depending on what access we give each organization, that indicates where they're allowed to deploy their database virtual machines.
And one thing to note on that is, you notice that it's very similar setup to how we have set up Tanzu with the namespace concept, so that we can tie in all of that same policy structure that we have for containerized infrastructure and for vSphere infrastructure, and tie it into that same database infrastructure. So you can have a common construct across all of your infrastructure operations and management. And I think that's a really important thing from a database administrator perspective, is that you now have the same logical constructs to operate in while you're trying to deploy and maintain and operate database infrastructure. You can do it in the same manner that you're doing it with your vSphere infrastructure, and the same management with your modern application infrastructure under the Tanzu umbrella.
Yeah, so that's actually a fun fact and a great point, because this actually came from the Tanzu portfolio initially, and we've actually decided to make it a standalone solution. So we're going to start out in the lab. You can, if you're not logged in, we have someone who can come around and help you get logged in. But the first thing that we're going to do, and again, because this is a very, we're focused on supporting really a lot of application developers here, so we wanted to make sure that we have a very robust API, as I mentioned before. This tool is built with an API first approach, so everything you can do through the UI, you can do via the API. Sometimes you can actually do more fun things in the API than you can maybe do in the UI itself. So we're going to walk through, we're going to leverage Postman today to actually do our first module, but before we do that, I'm just going to give you a little bit of an overview here of Postman in case you're not familiar with it. Within Postman itself, we have different environments that we can set up, and I kind of have those set up as each of our different users that can log into DSM. And we're going to be focusing on using our tenant user today, so you can see that I've got that one selected already. And then within collections, you can see that we have a lot of different, all of the different API options that are available. But we already have our tabs open for all the steps that we need to go to actually get logged in. We have our default information already saved for the DSM tenant user. So I've got all of that saved in variables. And when I go ahead and run this post the get access token, we're going to go ahead and it automatically runs a script that will save the output from that API call so that I can use it in subsequent API calls, and we don't need to do a lot of copying and pasting of tokens and all that sort of thing. So if I go ahead and submit that API call, we can see that it returned a 200 down here, so that's a good thing. And we can then also see that we have some outputs that were saved. So we're going to go ahead and then, actually those were inputs, sorry. And then we're going to go ahead and run the get namespaces API call, because we need to have both an environment ID and a namespace ID for the user that just logged in. So we need to get the ones that are before we can actually create a database, which is what our next step is going to be. So we're going to go ahead and run this one, and it's going to capture again, that environment ID and that namespace ID, and we can confirm that it ran successfully. And now we can go ahead and go to our create database step. So if I'm going to go ahead and look at the headers really quick. You can see that in order to create a database, we need some parameters, including the access token, which gives me the information about the user who's logged in, as well as the org that they're logged in as. So those are the inputs that are needed for this specific call. And if we take a look here at the body of this create database post, we have information that we need to supply, including things like the database instance name, when we want maintenance windows to be configured, and whether or not we're going to have backups configured and how often those are going to run, those sorts of things. We can enable protection. There's a lot of different pieces of information we can have here. We can apply vSphere tags if we need to. Those we can have very specific configurations set up for this database, including a database user. We've got an admin user that will get created, etc. So those are all the different types of inputs that we need for the create database step. So I'm going to go ahead and submit that request. And this one is going to be a little different. You can see that I have a 202 accepted. So it accepted all of the parameters, but it takes time to actually create the database. So what it's done is it's actually submitted it to the DSM provider, and it's going to be working on that now. So I'm going to go ahead and log into DSM. So I'm going to just open up a browser here.
One thing to know while she's opening that up is all those API calls that we just did are going to be available to all of your automation providers, ServiceNow, ARIA Automation, all of the other automation providers. If you are using cloud-based automation, all of that can be tied in with the API. So it's a very rich, robust API that you can tap into with your existing tool sets or an augment directly into the DSM or into vSphere as well. So very flexible, very powerful, and it allows a lot of control over who and what can produce what type of environments. And this can be done very, very rapidly and very, very consistently.
Absolutely. So I just logged in to the UI as the same user that I was logged into that I use with the API. And you can see now here in the operations option down below that I have a running operation. So you can see my database operation is executing, and it takes a little while to go out and create that database and provision and install create the virtual machine via the template that is provided and all of that. So while that's running, we'll go ahead and take a little bit of a look through the UI. So you can see this is just the dashboard when you first log in. Again, as a consumer or a user, I can see all of the databases that I own as an individual user, how much storage I've used, and all of that. Now, of course, this is a hands-on lab, so we start out with an empty, clean slate because we don't have a lot of space to have a lot of databases running all of the time when we're as we're using it in these pods. So if I click on database, the databases tab, you can see that I'm still provisioning that specific VM that I started. You can see information about what was requested, what type of database it was, what version, the size of the virtual machine that I'm deploying. So you can see I'm deploying this on a very small virtual machine for right now, and it's set up as standalone. It's not clustered and HA ready. If I have backups in the environment, you'll be able to see all of the backups and be able to manage those backup files from here. If I have any alerts, again, coming from those databases, those would be visible here. They can also be sent out through other messaging tools, whether it's email or other hooks, webhooks leverage to send out alerts. I can set up rules for my alerts, and you can manage those here, and those are kind of done by database. So these were created by default when I created that database. You can see my database name here. I can see a list of active and past operations in the Operations tab. One thing that's kind of cool, if we go in here and click on this operation, I can see the details of the history and the state, all the timestamps of all the different steps of this operation so far. But one of the most important things that I can see here is actually the Request Data tab, because if you've ever tried to reverse engineer an API call or work on an API calls to automate things only using documentation, that can be a little challenging. So here, any of the operations that you submit, you can actually come in and look at the request data and see exactly how it's formatted and what data was passed when that operation was submitted. So that's a really handy feature when you're working on coding with the API.
One thing to note on that is it's not only really valuable for the automation folks, but it's also really valuable for your auditors and compliance, because this can show exactly what happened when, where, why, and who initiated it, and what access token was used to actually manage that. Yep. So again, a very powerful tool, not just for the creation, but actually the ongoing operations management, and all importantly, that compliance and auditing, which is always a challenge from an IT perspective.
Absolutely. So we also have our environment set up. Remember when we looked at the logical constructs, we saw that we needed environments and we needed namespaces. So you, as a user, I can see information about the environments that I have access to. I can drill into that environment and I can see exactly what clusters I'm using, NTP data. I can see storage information and all of that. That information, I can see the health of my environment at a glance here. And I can, again, see all the events for this specific environment if I need to. I can see host metrics for the hosts in the clusters that are supporting this. And I can see my database metrics. So again, I don't have any databases set up right now. Storage, all of those things. And I can also manage my upgrades, and those are the upgrades of the database components themselves, right? I can also manage my storage and all of those sorts of things. One thing that's important to note is that we have each environment is tied to one of those agent VMs that is doing the actual creation of the databases. And so I can come in here and see the health of my agent at any point in time for this specific environment. If there are any alerts in my environment, I can come in here and see them again, and as well as environment level events. And the namespaces are used to carve up the infrastructure within any given environment and basically allocate compute resources or groups of bundles of compute resources. So again, I can come in and see a lot of that similar information. That actually just brought me back to the environment. So you can see here, I clicked on the wrong thing. So here we go. In the namespace itself, you can see how many databases there are in this namespace, which environment it's a part of, and the networking details, backup details, etc., and alerts and database metrics for the databases within this given namespace.
One thing conceptually for vSphere administrators, this concept is really like a resource pool. So if you think of this for a resource pool in vSphere, a namespace for databases is just like a resource pool. So we're allocating resources that you can have and also access and permissions wrapped around that, so that you can keep that kind of constrained, so that, you know, all of my Postgres, or maybe this particular application will get its own namespace. This particular group might get their own namespace. So you can logically or politically divide it up and keep it separate while maintaining overall control of all of those environments from an infrastructure perspective.
Right, and you can even divide it up based on network. So you could like have a namespace for production, a separate namespace for dev and test and those sorts of things as well. So it just helps you make sure that each bundle or group of VMs is isolated. And then we can see information about the organization itself that this user is a part of. So again, remember we had organizations that have both users and administrators. So that's really what I can do as a consumer of a user of DSM. I'm actually going to log out now, and I'm going to log in as an administrator so we can see a little bit more detail in here. So I've logged out, and I'm going to go ahead and log in as HOL user, administrator, there we go. So again, as an administrator, I can still see the operations that are running, even though this user wasn't the one that submitted that request. The org admin is still able to see all of the databases within that organization. And they can do a lot of the same actions and see a lot of the same information that the user can do. I know I have a list of like the actual different options that are available to each of the different users. And I'm actually want to log in as the provider admin next, so I can show you a little bit more information about the configuration of the tool. You can see,
and again, you can see the role-based access is really going to be important, so that you can delineate how you want to manage and operate the databases going forward. maybe I just want to be able to create databases for this users, while this guy is the DBA and he gets to administrate and operate the database. So it's very important we can actually constrain and control those permissions very granularly along the way.
So one of the things that you can see, I have a lot more options available now. The provider org, the user and the administrator in the provider org is the one that actually manages all of the database templates that we use to deploy those database VMs. So you can see when I log in as the provider admin, I have database templates that I can manage. I have different, I'm the one that can create and manage the organizations and assign users to those organizations and all of that sort of thing. I can also, of course, see all the databases, and I can still see the running operations across all of the different organizations. So if we go ahead and take a look at database templates, you can see that I have several in here for Postgres of different versions, and I have some in here for MySQL as well. I can pick and choose which versions I'm going to support, and I can do that through the publishing of templates. All of the templates for these open source databases are actually provided by VMware, so you can actually download these from VMware. You can come in here and you can publish and unpublish them, you can retire them if you need to, if you're no longer want to be able to provision that specific version again. But you also have the option to create your own templates, so you can actually come in here and add your own like SQL Server templates and that sort of thing. We aren't able to provide the SQL Server templates because of licensing restrictions. We can for the open source ones. So that's something that's important. But having that level of control so you can manage which versions you want to allow in your environment and how far back you want to go and that sort of thing. Let's see, they are also able to, yep. Go ahead.
Is there a limit for the number of databases that you can create based on a user profile or based on an overall organization?
Or are we talking about the different types of databases, like different, yeah. So we support Postgres and MySQL today, and we provide templates for those. We also support Microsoft SQL Server on Linux today. But those are the supported databases that we have today. And we chose those databases based on what we've seen our customers using based on telemetry data and the number of database servers that are actually running in VMware environments at our customers.
Great question, thank you very much.
And so one of the other things that we can see here is the ability to have updates available, and then also be able to manage those updates for those different flavors of database servers. And you can see that I have the existing VMs that we have today and what version it's on, and then I can actually go out. This is a lab, so we aren't able to pull in updates, available updates, but if there were available updates, we can go out and request those be downloaded from the VMware repository, and then you can push those out and schedule those updates for the different database versions. So we are still working. You can see that we're continuing to make progress on our create database. It does take a little bit of time, especially in this nested environment. I'm going to go ahead and open up a new tab, and we can take a look at in vSphere or in vCenter, and you can actually see that VM is up and running, and it's a lot of really what it's doing right now is getting all of the software installed and configured in that on that VM. So you can see I've got a resource pool down here. So my VM is created already and it's up and running, but a lot of what DSM is doing now is doing that install and configure components, right?
And you can see in that guest OS console that was back there, you could see actually there was the scripting of the install that was going through on that console. So you can actually watch the progress on the VM itself,
Yeah.
and you can see it in the DSM provider. So you can have your vSphere administrator see that something's going on. You can have your DSM owner and operator of that database see what's going on. So there's lots of visibility all the way through the process.
Absolutely. All right. And then the other thing I want to take a quick look at here while we're still waiting for that VM that database to get ready is I want to show you the Swagger API. You do have the Swagger API definitions that are available. It's
basically an API browser so that you can see the API calls that are getting made. And if you want to build an automation script, it's a great way to figure out all of the automation calls that we can use via the API call. So it's going to give you the GET or the POST calls on each of those APIs and allow you to browse through all of them to see, oh, I might want to use this for an automation engine to give them a t-shirt size for a database of XYZ. Oh, I can use this to insert a database provider or a database backup provider. I can use this to insert XYZ. So again, a rich API allows that automation engine to do all the work for you. And as you get through, and we saw that the slide earlier on with that whole process of creating a database from a request to completion, can be automated all the way from stem to stern, so that when you make that request in your provider like Remedy or ServiceNow or even Area Automation, it can give you that so that you can have an end user go in there, say, I want a database. It might go through an approval workflow, and then whoosh, off it goes through the DSM, and out at the end comes a fully provisioned database with a backup policy, security and compliance and audit requirements complete, and on the correct validated version of the database that we want. So if it's Postgres, you might have the option of maybe 100 of versions if you did it yourself, and you might not know which version that the organization has either blessed or which one's the current one for your current project. We can basically tie that in with the API and allow you to constrain that so that they can only pick the ones that are validated for this application or that user.
Yep. And you did mention t-shirt sizing, and that reminded me that we also do have the ability to set up what we call VM plans, or they're basically t-shirt sizing for the VMs that we're going to deploy for this. So you can, again, as a provider administrator, pick and choose what size options you're going to give your developers to choose from as they're deploying their VMs, right? And you can also see at the system level audit details that we talked about earlier for, again, authentication, all the login, log out, who's doing what in the environment. So you can see all the different operations and the users that were doing these things, as well as timestamps, whether things were successful or not successful, etc.
One question I have about that is, can we take those and put them into your security event management system as well?
So like a log collection? Yeah, of course. So we
something
can,
like
a
Splunk or something along those lines.
So we can actually set up our webhooks in here, our storage settings, and then we also have log forwarding, so we can forward those logs either to a tool like ARIA logging or Splunk
or whatever.
Yep.
It's just really important from a security perspective that all of these audit events get put somewhere where the security team aggregates them.
Absolutely.
So they can get a full view of, this user just did this, and this is why the request came in, and they can correlate all that. So they don't know that, they can understand that that's a legitimate request versus a malicious actor coming in.
Yep. And then we also have our webhook settings too, where you can actually push some of these out automatically to something like ServiceNow or to Slackbot or to some other option to send alerts to administrators.
And we do have some great web demos from Cormac Hogan where you can actually watch a lot of that in action,
Yeah.
and you can actually see a Slack bot actually get the notification that, hey, someone wants to create a database, can you approve this? And you click approve in Slack, and then it continues along in the Data Services Manager. So because we have such a rich API, we can go out and we can integrate into other tool sets to enhance the workflow or speed that workflow up while maintaining access control and authentication and workflow provisioning and approvals.
Absolutely. So you can see down here now I have a notice that my create database and my protect database, which happened automatically, are both completed now. So I can either click on I can click on one of these to see more details, or I can go back up to my dashboard and I can now see that I have one PostgreSQL database created in my environment. I can see all of the high-level details, and I can drill into this database now. I can see whether it's configured as a standalone or in a cluster. I can actually see that that password and user that I set up when I created that database. I can get the details around the IP so I can access this database and the FQDN and all of the other options that we have. I can monitor this database to see if it is healthy or not. I can get a review a variety of both health stats and database metrics for this database. Of course, we haven't really done anything with the database since we created it. We haven't really created any data or any applications using this database yet. And I can go in and I can manage backups for this database. I can actually take a backup now if I want to, and it will use the native backup options for the databases. And
One question, Kim,
Yep.
Are these databases thin or thick provisioned?
So that depends on how you provision them. When you provision via the API, you can choose whether you want a thick or thin provision. When you provision via the UI today, this is hopefully going to be changing in the near future, but today if you provision via the UI, it automatically selects thick provisioning. So that's one of the advantages of using the API for provisioning over the UI. Yep. I think we're almost done. So yeah, I just wanted to show the backups a little bit so we can actually see that we can manually take backups, but we can also have scheduled backups again and enforce those at a policy level so that the provider administrator can actually dictate how often those database backups happen for security purposes. Yeah. I just wanted to show that.
And again, everything you do in this GUI, you can do with the API. So if you wanted to script a backup, as an automated option, we actually have embedded in that API call that created this database a backup plan. So the backup plan was actually created via the API with that. So everything was created via API so that database is automatically going to get backed up on a schedule right out off the bat. Now you don't have to pass that off to a separate team. You don't have to go to your backup team and say, oh, I need to have this added into a database backup plan. You can actually specify that backup plan through the API and have it go to your backup provider, whether that's the internal built-in backups that we have that go to an S3 bucket, or if you want to pass it off to a dedicated backup that you've got within your vSphere environment already, we can do that as well. So again, very robust with the API that you can do a lot of pre-setup so that you don't have to do anything post-setup. So when you click that button to create the database through the workflow, it does everything for you and minimizes the what I call the ticket tax on as that ticket passing goes from team A to team B, it now goes into a queue for them and you wait. Now there's no waiting for any of that, and on top of that you get consistency. So
Absolutely.
I think both of those are very important.
Yep. And once we have backups available, obviously we'd be taking backups on a regular basis, especially for our more important databases, and then we have the option to either restore from a specific database or from a point in time backup as well. So you can see that we have a lot of different options in here, and those same options would be available to the user that created this. I'm still logged in as the provider administrator at this point in time. So that's really a high-level overview of the solution as we use it via the API and through the native UI. We do have a lot of other, like I said, we've got some great demos around leveraging this through ARIA automation and deploying that as part of a broader application, and then being able to manage and do backups and updates via that ARIA automation UI, so we don't have to have users learning to manage things in different portals, because the last thing we need is another user interface to do the similar things, right? And we also have some other fun updates that are coming later this year or early next year too, that you'll want to keep an eye out for. Anything else you want to wrap up?
No, I think that's a great overview, Kim. I really appreciate you taking the time to walk through the whole workflow, and I think this is really going to be an exciting product for vSphere administrators, whether they're on-prem or running vSphere environments in any of our hyperscaler partners or our cloud provider partners. This is going to allow a really easy way for our end users and our customers to consume database resources in an effective and automated manner.
Absolutely. Thank you, everyone. Make sure you take your survey.